Welcome to Programming Pi. Today, the topic which we are covering is a project with which we are classifying images of a banana and an apple through convolutional neural network. We are using Keras library to do this, and before getting into the project, let me explain how it is done. How do humans classify images? It's through features. For example, an image of a banana can be classified by humans as a banana through various features such as the color. The color of a banana is yellow, but the color of an apple is red in color. And a banana has a slight curve, a bigger curve in its appearance, but apple is spherical in shape has less curves than banana. These are the differences which we see in these fruits and classify them. The same with the neural network, the convolutional neural network. We are using certain filters and processes which convert the image into features and detect it. And the first step in it is applying a feature map. The red text which you see in between you 001, 100 and so on. That's the feature map which we are applying here. But why do we apply a feature map? A feature map is applied to get the important features present in the image. For example, the banana, the important features are the curve part. This is the important feature for a banana. The yellow part is the important features for a banana. But a normal image may not be transparent like this. A normal image has many background and other objects such as a banana may be placed in a table. So we need to only concentrate on the banana so that we get accurate results and not the table. So a feature map is applied to get the perfect features of the banana. And how does it work? At first, a feature filter or a feature map is taken, and slowly let us move the blue part to it. And let's check whether the feature map is matching with the input image which we have. We have to check the ones which are matching. So here in the top right corner we are having two ones, so it's matching. In the second row we don't have any matching elements of one. In third row we are having a matching element of one, so the output feature map we have two in the first column. So let's move it again, and we have come to the middle part. Here in the middle row the one in the left corner matches, and in the last row the one in the right corner matches. So again we have two matching elements, so in output feature map we have two. Again let us move it. Now let's see, the one in the top row matches, and the one in the second row the left side matches, and the other two ones on the bottom row matches. This shows that all of the elements matches, so we have four matching elements. So let's give the output feature map to be 4, such that it slowly moved to every part of the image, and we have calculated the feature map. And the output feature map is calculated by us. Now the next step, ReLU. What does ReLU mean? As you can see in the graph, the value of y lesser the value of x or y lesser than 0, that is, if it's in minus it can be converted directly into 0. Why are we doing this? It is to reduce the non-linearity in the image. For example, here's a black and white image. Now we have a small problem in it. Now the image is too complex to be solved because it has a lot of comprising layers. Now if you can see, from black to white there are many colors involved in it. For example, while we move on to this image of this building, it contains black, it contains white, it contains gray, a darker gray, a lighter gray, and many other combination of image. It's hard for the neural network to simplify it, so we are applying a ReLU function. As you see, we are applying a feature map. We already did it in our previous example, and after applying ReLU function to it, we can see that the black and the gray ones are removed. Only two color, it's converted into two color image, but still now you can see certain features such as the building and the huge skyscraper building, but the other features are disappeared. This is what we want. It concentrates on the building and the linearity is gone. Now max pooling is an important step in the neural network. There are many type of pooling in it. We are using max pooling, but why are we doing it? It's to reduce the number of pixels in image. This is a smaller featured image, but in real example you may get a larger image than this. So to reduce it, we are using max pooling. After applying it, as you can see, in the first yellow block, we are having the maximum number of 6. So here we have a 6. In the second green box, the 4 elements, we are having the maximum of 8. So after max pooling, we are having the green box as 8. And the third one, we have 3. Again 3. And the fourth one, we have 4, 4. This is known as max pooling. And there are many other layers of pooling such as average pooling, which takes the average of these numbers and can be applied. Now flattening, passing on to the neural network, it's another important step. We got this layer after pooling. Now we need to pass on it towards the neural network so that we would get an output. Now the image is totally processed. Now what we have to do is just send it towards the neural network, but you can't send these four numbers directly. We have to flatten it, so we have to convert it into a 1D array. That's one dimensional array. So we have converted it and we are passing on through the neural network, and it predicts the output. Before moving on to the major part, let me explain a simple explanation on neural network. What is a neural network? In a neural network, the input is added. In convolutional neural network, we are having the pool layer 6, 8, 3, 4, or any other number. You may get a lot of numbers during this process, and we are input in the input layer. We are providing those numbers, and each of these webs are nothing but weights of the neural network, are connecting each other. And the weights of the neural network, weights are the most important component of the neural network because it plays an important role of the neural network. What does weight do? Let me explain. After providing the input, a simple formula is applied to every neuron in this neural network. These round structures are nothing but neurons, and a final output is predicted. But as you may think, the weights are randomly assigned during this process. So the output would surely be not the true one. So to make a correct prediction of the output, we have to provide the neural network with some back propagation, that is changing of weights. Now think and see. After assigning the input and with some random weights, we get the output as some other fruit, for example apple, but the predicted output should be orange or banana. So we need to find the error of the neural network and back propagate it to update the weights. After updating weights a lot of time, we finally get the right answer. Then the neural network is fully trained and we are ready to go. And the folder arrangement for this project, this is a very important part, so don't skip it. At first, make any folder with any name. A folder with any name. In the folder you need two subfolders, that is test and train. In the test folder you need two other subfolders, that is folder name banana and folder name apple. The name doesn't matter, but in both test and train you need to have the same names. For example, in test I have used the name as banana for a folder and apple for another one, as I did for the same in train, banana for a folder and apple for the other one. You can use any other name. And in test set we are having 200 images for banana and 200 images for apple. In train set we are having 800 banana images and 800 apple images, and total we are having 1000 banana and 1000 apple images. But how do you get this much images? So I got a web scraping project from the internet, so it's very helpful to get images from the Google. I have provided the link in the description below. Let me show how it works. So open up the web scraping project, it's given in the link description below, and paste it in a folder. I've just given a temporary location for it, and type what you want just here. Now I want images of apple, and the images are provided in the description below. I pasted the images in this folder, and it's divided into test and train. In train I have class 1 and class 2. You can rename it as apple and banana. Here I have 800 images. So in training set you need to have 800 images of apple and bananas. In test set I'm having 200 images of apple and 200 images of banana. This is how it works. Now let's move on to the coding. This is the coding which involves. At first, you are importing the necessary libraries for it. We need NumPy, Keras, CV2, and OS library TensorFlow. Now let's begin with it. At first, we are using image data generator. It's to just make some. And now let's get into it. At first, we are importing the train. We are importing the training set from the location where it is stored. As I already said, I have stored it in Python C in a folder, and inside it train. They are the training images. Don't specify the class, that is whether apple or an orange. It automatically considered it. And class mode is equal to binary. What does it mean? That means we are having a binary class. Binary class is used to the classification of two images. There are many types of class modes such as categorical or input, but in our case we are using binary because we are comparing only two images. The second one, test set, is the area where the test images are stored. So I have specified it, but here you should specify the location where your images are stored. The target size is just the resizing of the pixels, 64 into 64, the batch size, and the class mode again. And we are building a neural network here. We are building a sequential class, and we are adding the first neural layer, that's convolutional layer, and we are having 32 filters here. I've already said this, and the activation is given as Relu. Now the second one, and the input shape, it's 64 into 64, and 3. What does 3 means? It's the RGB, red, blue, and green. If it is black and white image, then you can specify this as 1. Now, and we are adding another layer for max pooling. We have already talked about max pooling and the pool size. That's the number of layers which is used for pooling. For example, if it is 2, a 2 column is classified, and the average and the maximum is found from the two numbers. Now we are adding another layer for convolutional layer, and we are adding a max pooling layer, and finally we are flattening it. I have already said flattening is done to make it go through the neural network. Now we are adding a dense neural network. Here comes the neural introduction of neural networks, and the unit is the number of neurons in the neural network. It's 128, and the activation is ReLU. cnred convolutional neural network dot add. We are adding again a dense neural network with input 1. But why we are having an input 1, unit 1? It's because it's the output layer. In output layer we are going to have only one neuron, and the activation is sigmoid. But what is the sigmoid activation function? The sigmoid activation function is used to convert the result which we get between 0 or 1. It's very useful because in our case, if 0 means apple and 1 means banana, and we are finding the loss. And finally, here the training begins. That's epochs. It's the number of time the training set runs. I have set it to 25. I think 15 goes well, but the more you set the epoch, the more the time it will take. Now we are defining the video camera. I am using camera 1. That's the but in default camera 0 refers to your first camera, and camera 1 is the second camera. I'm using my second camera for recording. Now the image from the camera is read, and the image is shown to you through this line, and the image is written or saved in any location which you mention. You need to change the location here. Then the image is loaded into the neural network. It is converted into an array of numbers, and the result is predicted by the neural network. And finally, if the result is equal to 1, it prints apple, or is equal to 0, it prints. If it is 1, it prints banana, and if it's 0, it prints apple. And finally, it removes the image with what we have done. Then again it loops again and again until we close it. Now let us run it. This takes some time because I've set the epoch to 25. 25 epochs take a lot of time, but according to the speed of your computer, it changes, and the number of images you have added. Feel free to change the number of images I've added, because if you're adding 2000 images, it would be better for it to predict it. I've just added 1000 images for banana and 1000 images for apple. The more images, the more accuracy. But be aware, because the more and more input causes a special condition known as overfeeding. In the process of overfeeding, the neural network may not work properly. And the accuracy is also set here. And as we can see, the loss is constantly decreasing and the accuracy is increasing. That shows a good sign. And our neural network is performing well. And finally, we have come to the end of the training session of the neural network. And as you can see, the loss is too low and the accuracy is getting higher. This shows a good sign of our neural network. And the images of these 1000 images of apple and 1000 images of banana are given in the description below. It's given as a zip file, so you need to unzip it. And this is the last epoch. And finally, the camera is connected successfully. And it's showing banana and default. That's because we have set it to binary. In binary, there's just two values. So if it can't detect any of these values, it shows a random value of any of these two. For now, it shows banana. Let me place apple in front of it and let's check its accuracy. It successfully finds it as an apple. So let me change the position of it. Anywhere I place it, exactly shows it as an apple. If I remove it, it goes. So it shows the neural network is perfectly trained and can detect images and process it perfectly and detect the name of the fruit which we keep in the place. For example, now if I keep a banana in front of it, yes, now it shows banana. It's because a neural network works. Now let me show another best example. For example, I'll keep images of a banana from a phone. It shows banana. A neural network works. But if I keep a image of apple, it shows apple. So a neural network is perfectly trained and works in a proper condition and can detect